Hey guys, welcome back to the video. Today I am excited to start a series of AI projects. We are going to see different AI projects and we are going in depth in order to understand the whole AI framework because the world is moving towards AI, and if we don't learn AI we will be left behind. So with that purpose I am starting this particular series of videos where we will be learning in depth of AI. So welcome to the first video where we will be looking at one project. What project? That is basically you have to write something with your own handwriting, some number you have to write, and the project or the program will identify which number exactly you have written. Alright, isn't it interesting that machine will have to identify which number you have written? Alright, so again, it is not a magic, it is not some superpower, but it is a pure algorithm by which we will understand this program and step by step we will implement it. Alright, so let's start today's video. So first of all I will talk about deep neural network. Alright, so we have already seen this particular topic in before videos. I have mentioned all the concepts. If you haven't watched it, you can just go watch it and make sure that you understand the basics of deep learning. Alright, with that let's start today's video. So first of all, what will be given is one handwriting will be given, handwritten picture will be given, that is of 28 into 28 pixels. Alright, something like this. You can see the image as 5041. Different handwritings will be given. Our program have to be smart enough to understand which number it is. Alright, so let's break it down. So first of all, in simple words, I have to make this particular neural network. Alright, where inputs I am passing, some hidden layers are there, that is known as again black box, where we don't know exactly what is happening inside, how it is happening and why, what is the reason behind it, we don't know, but something good and something beautiful is happening inside this black box, that is known as hidden layer, and after that it is giving me output. Alright, so this is the overall network that we are going to build without using any libraries. We won't be using any TensorFlow or PyTorch library, but we'll be using total NumPy and total algorithm will be understanding step by step. Alright, so follow it and I am sure that at the end of this video you will understand it thoroughly. Alright, let's start it. So first of all, let's load this images. Again, you don't have to click all these images. All these images are already there. There is a MNIST which is providing you all this data that you can upload it in your project using Keras. Alright, from Keras you can upload it. So these data sets are provided by MNIST. Alright, let's start it one by one. Let's do step by step. So the first step, what is the first step? Load data from Keras. Okay, this is a library from where we can load the data. Alright, you have to understand the goal. The goal is simple. You are given a picture, you have to predict which number it is. Alright, for that what we need to do, we need to first train our model. Whatever the model, smart model you are having, you need to train it first in order to understand, make it smart enough so that whenever you are giving next input, it should be able to predict. That is the only goal of today's project. Alright, so first we have to load. So let's load it without delaying it. First what I'll do is import NumPy as NP. We are importing this NumPy because array we need to use, large data set we need to use. That is the reason I am importing NumPy. Alright, after that we need to import Matplotlib so that we can use graphical representation while doing it. So matplot pyplot as plt. Alright, so I'm just importing this libraries. TensorFlow dot Keras dot datasets import MNIST. Alright, so check line by line. First of all, what I'm doing, NumPy I'm importing just to use the array. Matplotlib.pyplot as PLT, I'm just naming it. From TensorFlow.keras.datasets, we are importing all these datasets. So this will be looking something like this. Okay, this will be looking something like this, where we are loading the whole data set. Alright, so from import MNIST, let's run this and check any error is there. After that, we'll move to second. Alright, so the first step is done, there is no error. Let's go to second. So before starting the main neural network, this is our goal to make this neural network, but there's some process. The input directly, it can't be filtered. Okay, first we need to process. So that process comes under second step, that is pre-process data. First we need to pre-process data. That is simple. What we need to do is observe here, read this first of all. In the MNIST data set X train, there will be two type of data, that is X train and Y train. Alright, so X train is nothing but input images that you will be using in the training and testing. That testing, the output part, that will be given in the Y train. Alright, so X train will consist of all the inputs as an image. Y train will be consisting the output. Let's say one input will be there, handwritten 2, that 2 will be there in the Y train. Okay, 2 arrays are given. So first of all, we are taking that 2 things. Let's take that from the data set. Okay, so how I will take, first of all, you take bracket X train and Y train. I am taking in this variable as a tuple, I am taking, and this I am keeping it as blank. Okay, two type of data sets are there, one is training, one is testing. Okay, we are not testing anything now, so I kept it blank for now. I am just doing this. From MNIST, I am loading the data. This is how you load the data. I hope it is clear. Alright, let's just run it again, and then we will do this. We will start pre-processing. So this is done. There is no error in this. So after this, what we are going to do is we have to this pre-process data. So understand this, in each and every image, basically one image will be looking like this. This image you need to divide it into 28 by 28 pixel, that is 728 something. Yes, 728 numbers will be there. That number you need to flatten it. Why flatten it? Because it is in the two-dimensional matrix. We have to make a one-dimensional matrix, right? So that we can follow the formula. Which formula? Basically this formula we need to implement. Just observe it. This formula we need to implement it, right? So the basic formula is inputs will be given in the one-dimensional format, that will be going along with the weights, that is X into weight plus bias we need to do, and then we need to apply activation function. That is how hidden layers, and that is how neural network works. So I am hoping that you guys know the basic of neural network. Alright, so what I am going to do here is I am going to flatten it. Flatten and normalize it. So how I am going to flatten it? So the first step is X, I am storing something. What I am storing? From that X train is a variable where I am, X train is a variable where I am storing all the data. From that variable, I am taking 10,000 images. 10,000 images I am taking to train the data. I'm not taking the full one. 60,000 inputs will be there. Here you can see 60,000, 28 into 28 pixels, but I'm just taking 10,000 for our project. All right, and then what I'm doing, I am reshaping it to those 10,000. I am reshaping it to one dimensional. That is how it is represented, -1. All right, so I'm reshaping those 10,000 to -1 dimensional, and each and every value, what I'm doing, I am normalizing it. How I'm normalizing it? I'm dividing each and every value. So basically pixels. What are pixels? Pixels are nothing but color. Alright, that color will be defined by 0 to 255. Any number will be there. So that number I am dividing by 255 so that it comes from the value of 0 to 1, it will come. So that 0 to 255 number will be decrement, or that will be normalized to 0 to 1. Alright, why we are doing this? To make our model work. Alright, we can't work with large number, we have to work with a very small number, that is from 0 to 1 we are normalizing it. Alright, that is how we are shaping it. After that, what we will do is y train. What we will do is y train I am taking just those 10,000 values. I am just taking 10,000 values here. Alright, let's just run it again, so that in order to avoid mistakes. Alright, so till here we have done pre-processing. I hope you guys are understanding. Next step is we have to do one hot encoding. Converts level like 3 to this. So the output will be there. I told you, right? Y train is nothing but output. What we need to convert, we need to do one hot encoding. What is one hot encoding? It simply means that if I am giving you 3 as an integer, you have to convert it in a matrix format, that is one dimension. That is, you can see here, you have to convert it like this, 3 to this. This is known as one hot encoding. Alright, we have to write a function for this. So let's write this a function, def one hot encode. How we can do it? We can simply pass two variables. What variables? Y I'll be passing, and num class I'll be passing, num classes I'll be passing with 10. Alright, 10 classes are there, right? How many numbers are there? 10 numbers are there, so 10 class I am passing. Alright, I hope you are clear till here. After that, what I'll do is encoded equal to that numpy np dot zeros. I will fill with all the zeros first. How many values? Len of y values with num classes times. Okay, that many times, basically 10 times I am filling all that particular matrix with zeros. Alright, next is I am putting encoded. I am arranging it. I am arranging with np arrange. Arrange spelling is one arrange. Okay, one r, not two r. And len of y, len of y, make sure you are writing it correctly, all the small letter and capital letter, and then you have to put it 1. Alright, encoded np in that particular index. What index? np dot arrange. You need to do what? Len of y of all the, from the array, what you need to do? Len of y from that, in the y, that many numbers you need to put 1. In that index you need to put 1. Alright, so I am finding, basically if it is 3, I am going to third index and putting 1. As simple as that. Alright, this you need to remember, this particular function. After that you need to return this encoded matrix. This is again a matrix. Alright, after that what I have to do is I have to make this encoded, and then I have to call this one hot encode and then pass y. Alright, this is how you run encode. So once you are done, what you have done is 10,000 images you are taking, one by one all the images you are putting x and y. Two things we need, that is x and y. Alright, so like this we have done. Let me again run it so that we can remove the error. Alright, so step 2 is done with this. Alright, so once after this, what you will be doing is first x, that x we have normalized and flattened. How this? Imagine this is a matrix, then what we did, we have put it in one dimension matrix. After that we have, okay, normalize means so that each value is from 0 to 1. Alright, this is the way to, first step we have done. Second step is encoded, y value encoded, so that we will be easily doing the dot product, cross matrix, cross multiplication matrix. Okay, that we have to do. So this is the second step. I hope you are understanding. So basically this will look something like this. After normalizing, the x will look something like this. It is a huge data. Alright, it is a huge data. Each and every image will be, each and every image I'm talking, one image will be consisting around 728 pixels, 728 matrix, one dimensional matrix. Alright, so it is quite huge data set. Next, let's talk about activation function. Again, here I'm not going to waste too much time on activation function. What I'm going to do is I'm just going to write here the activation function. So basically all these are nothing but all these are just a formula that you have to understand. All right, so I'll just explain it quickly so that you guys can understand it. All right, nothing much. So this is the formula here. So if you have seen my earlier videos, you would know that what ReLU does. ReLU, any number, it just will find from 0 to x. All right, it will squeeze the number from 0 to x. If the number is lower than negative, it will bring it to 0. If it is positive, then it will keep as positive. All right, that is what ReLU does. ReLU derivatives, what it does, if the number is 0, near to 0, it will bring it to 0. If it is the number is near to 1 or more than 1, then it will squish it to 1. So 0 or 1 it will keep. All right, so that is what ReLU derivatives gives. Softmax will give you the probability of what each and every number, let's say 0 to 9, which number is probability is how much, that will be defined by softmax. Again, cross prediction will do how much cost function difference are there. So basically these are just a formula that you need to understand. You can go in depth. Now in this video I'm not going to talk, otherwise it will be too long for you to understand. So activation function is done here. Now the main part comes here. Main part that you need to understand is this particular initialization. All right, this in simple word, this is how your neural network looks like. Input layers are nothing but x, hidden layer are the hidden layer, h1 is h2, it will be defined by those. Again, those weights, so it will consist of weights that we have to make those weights first, and then we have to do dot product. All right, and then we have to take bias also, and then we have to pass it in the activation function. All right, that is here we are taking it as ReLU, and again we have to pass it through the output layer. All right, so let's start one by one. So see here, we'll follow this step by step. So first of all, what we'll do is we'll have to initialize each and everything. Before that, let me just run it and check. All right, no issues till here. So what I'll do is, all right, so till here we have done all this. Now we have to initialize. How will initialize? So first of all, input size. What is the input size of each and every matrix? Each and every matrix size is 784. Okay, 784, that is basically 28 by 28. All right, I hope you are understanding input size. So see, input size, input layer. Next, hidden layer, how much size? Hidden layer size is 128. All right, this is your wish, but I'm taking it as 128. Okay, accordingly to the significance what you want to create. So in that way you have to, if it is complex, you have to take more hidden layers. If it is little smaller, then you can take, I'm here taking 128 hidden layer. All right, output will be consisting of output layer, output size I will keep it as 10. All right, 10, 0 to 9 is 10. Now epochs, how many epochs I want to run? Epochs is nothing but how many times you want to run. So I am just writing 200 times I want to run that loop. All right, learning rate I'll be keeping it as 0.1. all right, 0.1 by default. We will keep it as 0.1 so that it learns in a not too small, not too large. All right, that is what we have initialized the first thing. All right, so after that what we'll be doing is we have to set the weights. So here weights should be random, right? If you have seen the previous video, again you will understand weights should be randomly put it in so that we can multiply with that x, and weights we can do cross multiplication and we'll be getting the hidden layer. So basic formula is this is the basic formula, x into w cross multiplication plus bias. All right, so let's do it. Weights, let's initialize it. All right, so weights, how will I initialize? First of all, I have to keep random seed. All right, random dot seed. So this will initialize, this will not initialize every time it will keep the same value. All right, otherwise it can be giving random value. So every time we start, it will be giving one fixed amount of value that we can start with. All right, random set. After that, what we'll do is w1, I am going to start np. Basically np is the numpy dot random dot rand n, and then I'm going to take input size. Input size is what I'm passing. All right, how many size of the weights, it is dependent on the input size, right? So input size and hidden layer. All right, so you can check it here. All right, so hidden layer, input size and hidden layer, I need to make it, squeeze it again, that I'll do. But before that, let's say b1. So b1 is nothing but bias. How many bias? Hidden layer times. So the one is a row and column is hidden layer. So one row, many columns will be there. That is nothing but hidden layer. So we need to do cross multiplication, right? So that's why rows and columns are required. W2 is also same, random hidden layers to output size. All right, so basically this neuron we are following, this we have to follow. All right, so here you can see w1 into x plus bias equal to the layer. So this size we are setting. All right, this size depends on the previous one also. So here you can see w1 column is nothing but x, input row, how many rows, so it is interrelated. All right, that is how we are doing here. First input size is this input size. This input size is row. All right, this is column. This many columns we need to take it here. This is a bias for bias. So again we are adjusting the row column. If you know the matrix multiplication, how it works, you need to balance it. All right, so this is how it works. After that, what I need to do, I need to squeeze it. How can I squeeze it? I can squeeze it using sqrt square root. I am putting, and each value I am dividing with input size, so that it can squeeze it and it can normalize. So basically I am doing normalization. All right, so because the neural network works better with the small numbers, all right, rather than large number. So hidden layer or hidden size, I can just put as hidden size, hidden size, hidden size and hidden size. All right, so like this we have designed this initial weights and inputs. All right, I hope you guys are understanding till here. Let me just run it and check if any error is there. So one error is there that we need to solve it. So what is the error? Random.rand in input size we have taken hidden, and then we are multiplying with np dot layer. Okay, this hidden layer, it should be size. All right, so let's check it again. So this time no error. All right, so this errors and all you need to make sure. All right, this is the fourth step. Now let's do the actual part, training loop. All right, we have our all inputs are ready now. This you can take the reference from. If you are confused, you can just take the reference from here. Now we are going to do the actual training. All right, let's do it. So first of all, we need to run a loop. All right, we need to run that many loops. How many loops? For epoch in range, how many times? That many times. Epochs. Epochs is nothing but here I have given 200 times. All right, so it will run 200 times. So let me just, it is suggesting me some code, so I'll just explain you. First of all, observe here. Here I told you this is the actual diagram. So see here, first of all, what I'm doing is I'm using NumPy. Here I'm not using any library. Okay, TensorFlow or PyTorch will give you some library that you can use. Here we are not using any library, we are just using raw mathematics. All right, so np dot we are using dot product of the x this x value you can see with the weights. So we are doing weights and we are adding the bias, okay, bias, and then we are finding the z1. So this is the actual value that you find. After that, what you need to do is ReLU, so that you can find the activation function. Once you find the activation function, you have to pass through that activation function, and again you need to take the weights. So this time this second layer from here to here, again you are going. So this second weight layer and activation function, you need to do dot product and then add the bias, and then you will find again Z2. Once you find, you will again have to do softmax and then to actually find the activation function, that is the last one. Alright, this is the first. Here you are doing forward propagation. Alright, forward pass. Alright, now it is not learning here. It is just giving, it will give a random answer. So that random answer, we need to find the difference and then we need to go backwards so that it can learn actually. Alright, so first here we will do back propagation. So this is the magic that it occurs. Propagation. Alright, back propagation. So what it does, back propagation. So I need to find the Alright, so here I am finding the difference. How do you find the difference? So first I'll do, alright, so look at here, A2 is my final answer, right? A2 is my final answer that I'm subtracting with Y encoded. What is Y encoded? It is nothing but the Y result, the first one, image. So if you see here, it was the this is Y encoded. Alright, this we are comparing with which one? This we are comparing with the final value, that actual difference. Your predicted and actual difference, what is the difference? So this I am getting the difference here. Alright, after getting the difference, what I am finding out again is weight. How much you need to change the weight. Alright, so that I am doing the transpose of A12. A12 is nothing but if you go backside, you have to go backside, right? So that going backside, you have to go and transpose. Why you are doing transpose? Because the size of the matrix will change. You have to transpose it so that it can adjust accordingly. Alright, so transpose dot dz2, that is the difference. You need to transfer and multiplication. Do the multiplication again backwards so that it can learn. Alright, db2 also you need to change so that it will be the sum of d this one, and it will, you have to keep dimensions, true dimensions. Alright, keep dims means it will take care of the dimensions, otherwise there is a chance that it can give you the wrong answer. So what we'll be doing here is, what we need to do, one more thing is, we need to normalize it. How we can normalize it? We have to divide it by x. What is the x? Okay, x dot shape of 0. Alright, x is the actual input. Here x is the actual input, right? So that x we are taking and we are finding the what is the size of it and we are dividing it. Alright, so till here I think no problem should be there. Alright, so we are done with back propagation. Now we have to update it. Let's just keep going on. Update. So we need to update it, right? Once we find the difference, we have found the difference, we have done the back propagation. Now we need to update it. Update the word, update weights, not the actual input. Input we don't need to update. So update the weights. So how we can update? This is how you update. Okay, W2 B2 you will update with that LR of difference. That which difference? This W2 B2. Okay, this you have to update, and then you have to update again W1 minus equal to again LR of into D W1. So we have to update here. I have not updated. Okay, so this I have done just back propagation one time. All right, so second time also we have to do, right? For DA1 we have to do again, once again we have, so see, one step we are coming back. Again we have to come one more step. All right, so that step is da1 np dot. Again we have to do what? dz2 comma. So this is the function. So what we are doing is, again we are just coming back, take the same value from this step, from the second last step to the first step we are coming. All right, so dz2 w2 dot t, again we are just doing the cross multiplication, and then we are finding out dz1 dw1 db1. We are just coming back, that's all. It is just a pure mathematical formula. All right, so here we are using ReLU derivative so that we can either keep it as 0 or 1, and then we are doing x, same thing we are doing here also, and then we have to close it. All right, just we have to keep this as this, keep dims equal to true, so that it can rectify the mistakes. X dot shape, here also x we have to divide it, normalizing, nothing else. All right, so here one good thing about is it will suggest you the codes. All right, if you know how it works, then it is very easy for you to understand. All right, so once we have done this, you can see here, once we have updated all the things, then we have to update w1 and w2 also, w1 and b1. So b1 I have to update, again bias is nothing but lr into db1. all right, so once we have done updation, what we are done with, forward propagation, we are done with backward propagation. Now what we have to do, we have to update also, we have updated weights, we have updated bias. Now we have to just print it. Okay, now we have to just print it so that we can understand how exactly it works. All right, so what we'll be doing is we'll have to print after each and every loop. We have to check how it is working. So all right, so I'll just copy the code so that you guys can understand. I'll not take too much time here. So here you can see, after each and every 10 times, after each and every 10 loops, we are checking the epoch and then we are printing it out. All right, so that here A2, I guess it is A2. All right, so we are finding the maximum. Here we are finding the C. After each and every 10 iteration will be printing, and the last one will be printing. This is nothing but last one. If your value is 200, it will be printing 199 epochs. All right, this represents last one, and we are finding the best one, last maximum one, argmax, np.argmax, the last one, axis is 1, and we are finding the predictions also, mean prediction, so that it can find out what is the accuracy. Accuracy is nothing but in terms of percentage we are finding out. That's why it is multiplying with 100 and it will find out 2 decimal point. All right, so I'll just check it till here if it is there, any error is there. All right, so basically this loss I have find out here. Okay, loss I have not find out, that is the actual thing. So I have to find out loss here. Loss is nothing but cross entropy and A2 y encoded. Okay, so we have not find out the loss, how much loss it is having. So now here we have found out the loss and then we'll run it. So this time it will, okay, so we are doing some mistake here. Cross loss equal to A2, it is small a2. Okay, so we are finding out the, now see, each and every time I have just stopped it, it is not I will run it again, but it is coming, it is running. All right, so we are finding each and every time accuracy, and every time you can see the accuracy is getting higher. All right, so after that last step, what we'll do is, it is not complete, we need to visualize it, right? So let's visualize it. Again, this function I'm not writing it as, it is just visualization part, it is nothing to understand much. So the last step I'll just keep it as visualization part, so that you can see the actual result, how it is actually working. All right, so that's the this is the understanding part, and last is visualization. All right, so let's check the final result. So you can see here the first epoch the accuracy is 12%. Next epoch, that is after 10 intervals, it is giving me 62. That is quite a learning. Alright, in the 20th it is giving 74. Like this it will go till 200. Alright, 200 iteration, and then it will give me the correct result. Alright, so if you can go it more, then it will be giving you more accurate results. Let's wait for the result. So yeah, it's quite interesting how the learning process, it learns again and again, and it will find you the actual thing. Alright, so one problem is here, so visualize. Alright, so this we need to change it. Here x and y is alright, but w1 we need to change this as small letter, w2 as small. Let's keep the, alright, let's do it anyway. I hope this time it will give me output. Let's check this time. So after 200 it should bring me some. Alright, so you can see here, congratulations, you have done the first project. So yeah, prediction here it is not true, here it is true. Prediction is 4 and the actual is also 4. Prediction is 1. So yeah, it is quite giving me quite a correct answer. Sometimes it will be wrong as because it is off. The prediction you can see here, it is 90%. Alright, if you do it more, it will be more accurate. It will go nearer to 100, not exactly 100, nearer to 100. So with this we have completed the first project. I hope you have enjoyed it, and literally it takes a lot of effort to make this kind of videos and in-depth videos. So I am expecting a support from you guys. Make sure you do support me and do subscribe and share it to your friends, those who are learning AI and those who want to learn in depth. Alright, with this let's finish the video. Thank you, bye bye.